नमस्कार मित्रांनो, we are discussing about the chapter elasticity, and in last lecture we have discussed about the cantilever. See, cantilever is a body which is fixed at one end and loaded at the another end. That body is known as cantilever. Now, in last lecture, we have discussed a case when the weight of that body, when the weight of that beam, which is acting as a cantilever, that weight was ineffective. Now we will see the case when the weight of the beam is effective. Means that we have to consider the weight of the beam in this case. See the diagram. Now again AB is nothing but a neutral axis of the cantilever, whereas this end A is a fixed one. And see, to this B end, this is a free end, to this B end, weight is applied, W. And therefore, this cantilever having this neutral axis, it is depressed and it takes a form A B dash, means A B dash, and this depression is through the angle d theta. Again, this is the point P. Up to this point P, we can say that this distance is x. So a total this distance is L, and this part is L minus x. And see, here we are drawing a tangent from P and tangent from Q, due to which again the tangent which is drawn through P is we get here at C. This is a point on this vertical line on BB dash. Again from Q the tangent is drawn and it is at a D, which is also on this vertical line BB dash. See now what happens. In this case, in addition to the weight W at B, the weight of the portion L minus X of the beam is also acting. This L minus X, this much distance, of this neutral axis, which having the weight, it is also acting at the midpoint or the CG of the portion. We know that CG is nothing but the point which is supposed that the whole mass of the body is concentrated at that point, that is center of gravity. So that if W, capital letter C, the weight per unit length of the beam, then this weight which is acting by the portion L minus X is nothing but a small w in bracket L minus X is acting at a distance what? L minus X by 2. See now, this much distance is L minus X and it is acting at L minus X by 2 on this. From the section PQ now, and therefore the total bending moment of the beam is. See now, for calculating the total bending moment, we have been seeing bending of beam and bending moment, how it is to be calculated. Here, W, this is a weight, and L minus X plus this W into L minus X is a weight acting at a distance L minus X by 2. From this we can see here. And therefore W in bracket L minus X plus W by 2, this 2 denominator factor we will take here, and square of L minus X we will take. Since the beam is in equilibrium, this must be equal to y into Ig upon r, or y into ak square by r. As from last we know that Ig equals to ak square. Friends, therefore by putting the value of this Ig equal to ak square, we know that, and by putting this y Ig upon r, or y ak square by r here, w in this equation L minus x plus w by 2 L minus x square, this whole quantity equals to y by ak square by r. And see, this r is nothing but the dx by d theta, as we know that is a small angle due to depression which we are getting, and this ex is a small displacement. And therefore now by putting this value for the d theta, and by rearranging the equation, we get d theta equal to w in bracket L minus x into dx plus w by 2 L minus x square into dx upon y ak square. And then from last expression we know that this dy, this is the last equation, dy equals to L minus x into d theta. And by putting the value of d theta in this way, um, see now L minus x is as it is, but this L minus x and L minus x it will be square, and this w as it is into dx as it is plus w by 2 in bracket this L minus x and this L minus x square is nothing but L minus x cube into dx, and divided by y ak square. Therefore the depression from that diagram, we know that y is the depression, and it is nothing but the dB dash of the loaded end B below the fixed end A is obtained by integrating the expression or dy between the limits 0 x equal to 0 and x equal to L. Therefore, by taking the integration of this quantity, and this quantity will be outside of the integration sign, w y ak square integral of L minus x square into dx between the limit 0 to L plus again w divided by 2 y ak square, this much quantity, integration of L minus x, this much w by 2 L minus x cube into dx. Now we will do first this work, that we will solve the integration of our equation. First we will see what about this, means integral of L minus x square into dx between the limit 0 to L. See, integral of L minus x square, this is the case in last means when we were finding when the weight of that attached to that cantilever beam was ineffective. In that case, L minus x square, that is in the form of a square minus 2ab plus b square. We get same thing, L square minus twice Lx plus L square into dx, and in this way L square dx means x, and minus of twice Lx square. Lx is x square means dx. This see, this dx quantity is for whole this equation as shown in here. Therefore, twice Lx square by 2 plus this L square means x, and this x, that is x by 3, between the limit 0 to L, and therefore here L square, this we will take the upper limit L minus this 2 to get cancel, and therefore this L as it is, and this x square means L square upper limit, and see here x is nothing but the L cube upper limit. We have substituted these quantities and divided by 3, and lower limit is 0. To this quantity we will subtract 0, and therefore automatically L cube minus L cube plus L cube by 3. This L cube will be 0, and we will take L cube by 3. Now see this another part, that is integral of L minus x cube into dx between the limit 0 to L. See now, again L minus x cube, the expansion of this equation, that is L cube minus 3L square x plus 3x square L minus x cube into dx, and between the limit 0 to L. See now, this L cube dx having the value x minus 3L square x square by 2 plus 3L then x cube by 3 minus this x cube plus integral of dx is x, and therefore x raised to power 4 divided by 4. Now see now, this is a lower limit 0, upper limit L. You see now L cube by 3 minus 3L square into L square, because we will substitute this ax square by the upper limit L square, and this is 2 plus twice L into L cube upon 3 minus L raised to power 4 upon 4. By solving this equation, this quantity, we will get L raised to power 4 and minus 3L raised to power 4 by 2 plus 3L raised to power 4 by 3 minus L raised to power 4 by 4. See now, this 3 will get cancelled, and here twice L raised to power 4 minus 3L raised to power 4 by 2 plus here 4 raised to L raised to power 4 minus L raised to power 4 by 4, and see by solving these quantities, 4 the 2 is 8 L raised to power 4 minus 4 the 3 is 12 L raised to power 4 plus this cross multiplication 8 L raised to power 4 minus twice L raised to power divided by 8, and therefore this 8 L raised to power 4 plus 8 L raised to power 4 is 16 L raised to power 4 minus this minus 12 L raised to power 4 minus 2 L raised to power 4, that is 14. And see, this is nothing but twice L raised to power 4 by 8, and 2's are 4 is 8, therefore L raised to power 4 by 4. This is the quantity of this integral value, and therefore now putting the values of integration in this equation, basic equation, the equation y is nothing but the y ak square multiplied by L cube by 3 plus w twice y ak square into L raised to power 4 by 4, means we can write WL cube by 3y ak square plus WL raised to power 4, this much quantity, by 8y ak square. For put this value, this is a W1 here, you have to say this W1, and therefore the depression Y, which is in the case of cantilever, when the weight of the beam is going to be considered, means in the beginning this was the case, you can see, when the weight of the beam is effective, and for that purpose if we want to calculate the depression y, then we have to uh, we having the formula W1 L cube by 3y ak square by W1 L raised to power 4 8y ak square. Thank you very much.